My name's Nick Stroh, Chief Architect for ICG, and I'm going to show you a LUX project we've been working on recently. LUX is our real-time data exploitation platform. It does complex event processing, machine learning, streaming analytics, and real-time alerting on high-volume streaming data. Now typically, a production environment for LUX is one or more rack-mounted servers, on which we can process billions of events per day. But lately, we've had more interest from customers in small form factor deployments, so we decided to run LUX on this. It's a commercial off-the-shelf single-board computer. It costs around $200 and has less processing power than a new iPhone. Loaded with the LUX data processing engine, we'll refer to it simply as NanoLUX. What the NanoLUX concept enables us to do is move LUX out of the server room to be forward deployed and co-located with sensor platforms for real-time edge processing. In a standard LUX deployment, there's a single instance of LUX in a centralized location, processing and correlating all the data feeds available from that location. With NanoLUX, we can deploy instances forward on drones, CubeSats, or other sensor platforms to process data on-site, only reporting back a small subset of the data that matches rules and analytics. Here, analysts can work in a command and control capacity, monitoring results from all NanoLUX nodes and pushing new rule criteria to adjust and fine-tune their operation in real time. Now let's see a quick example of NanoLUX in action. So the setup for this experiment is the LUX user interface running in the cloud, accessible from anywhere in the world, and this single NanoLUX processing its local environment right here in this room. I can create alerting rules through the user interface and direct them to be sent to this NanoLUX node, which will send any results back to LUX in the cloud for analysis. Since LUX is a data agnostic platform, we really could connect any type of sensor or data source to this device and start analyzing. For the purposes of demonstration, we'll use two sensors, the first of which is the built-in Wi-Fi antenna. LUX will use the Wi-Fi antenna to look for networks in its vicinity and create a live data stream from the scans, including network SSID, MAC address, signal strength, and other attributes. So let's make a rule and see what Wi-Fi networks we detect. So with this rule, we're telling LUX that we only want to see one alert per SSID. So now that rule is saved in the LUX user interface in the cloud, and it's going to be sent down to this NanoLUX node. And so we should start seeing alerts when it does its next Wi-Fi scan. We could have written a more interesting rule using something like signal strength so that we could have actually moved NanoLUX around the room and seen the signal strength change, but we'll keep it simple for this demonstration. So if we select this rule, we'll see the Wi-Fi networks that were already detected. And we wouldn't expect this list much to change because it's just sitting here on the desk, but what we'll do next is we'll actually enable a new Wi-Fi network and see if we can detect it. So now I'll enable a personal hotspot on my phone, which will create a new Wi-Fi network that should have a distinct SSID from all the other Wi-Fi networks. My phone's network is NICXS, so we should get an alert on that in LUX. Takes a few seconds to enable the Wi-Fi network with an iPhone. So there's our alert for our new Wi-Fi network, NICXS. For our next example sensor, let's use something completely different to give you an idea of the variety of data types that LUX is capable of processing. So this is a USB web camera, and I'll plug it into NanoLUX. It could just as easily be any type of camera, but you'll see that it lights up and LUX detects that a new camera is available. And what we've done is we've loaded NanoLUX with a facial detection classifier. So I'll point the camera at me so it gets a good look at my face. And what it's doing is it's doing the real-time video processing onboard NanoLUX using that machine learning algorithm. But we can just as easily swap in any type of object classification in video or really detect data of any type within NanoLUX. We just want to give you an example of video detection as well as the previous example, which was a text detection. And you see right away we start getting new results in LUX, and you can see some screenshots there of my face. And these screenshots look a little funny because they've been pre-processed for that cascade classifier that we have running that detects the faces. And that's a preview of what we're working on with NanoLUX. Again, I want to stress that the product is software and very scalable software, so it's not tied to any particular hardware or sensor. Pretty much anything that runs Linux we can install LUX on, and any type of text or multimedia data feed we can process. Thanks for watching.